Hello, Calvin Jones here with ParkTool Company. In this video, we're going to walk through the process of crank removal and installation for the self-extracting style of cranks. If you're not sure what type of crank system you have, watch this other video and you'll be guided to the proper removal and installation process. Otherwise, thanks for joining us and let's begin. A self-extracting system in the crankset allows the arm to be removed without a crank puller. On non-self-extracting crank systems, like this one, a crank puller is used. But in self-extracting systems like this one, the retaining ring acts with the crank bolt to function as a crank puller when the bolt is loosened. So self-extracting systems are useful because it takes only one tool to remove the crank. Typical tools and supplies for this procedure include a pin spanner for the retaining cap, sometimes a hex wrench for the retaining cap, hex wrenches for the crank bolt, a mallet, torque wrench and correct bits, thread lubrication, and a rag. The process of removal begins with knowing what not to do. Do not remove the retaining ring in the one-key system. In fact, it's a good idea to check the security of the retaining ring in the arm. Some retaining rings use a large hex wrench to tighten into the arm. This one uses a 16mm hex, not a common size for a bike shop. You can substitute a large bolt with a 5/8 inch hex head as our 16mm. Retaining rings will often have a directional arrow on how to tighten. This one tightens to the left, and it also uses a pin spanner. Engage the pin spanner, and for this one, tighten to the left. Now let's remove the arm. Use the hex wrench size that fits through the retaining ring into the crank bolt. Turn the crank bolt counterclockwise until the arm slides off and away from the spindle. Next, take the remaining arm and pull it out of the bottom bracket, and it's out. Here's a quick tip before we get started with the process of installation. It's important that the splines of the spindle mate properly with the notches in the crank arm. Some models of cranks have a particular problem where the crank bolt will engage and thread before the spindle notches have a chance to align. On these models, make sure you're holding that spindle properly aligned to get the notches fully threaded onto the splines. Now let's begin the process of installing the crank. We're going to begin with the 2-piece crank sets. Next, we'll show you the 3-piece crank systems. Begin by greasing the surface of the spindle, the splines, and inside the threads. Install the arm with the integrated spindle through the shell and out the other side. It may require some tapping with a mallet to encourage the arm to come all the way through. Install any washers that were present. And install the left arm. Start the orientation 180 degrees from the first arm installed. And thread the arm in place. And tighten fully to manufacturer specifications. Typically, that's from 40 to 45 Newton meters, quite a high torque. Use a torque wrench when possible. The 3-piece cranksets have an arm attaching to either side of the spindle. For the spline spindles and the spline cranks, we want the spindle and crank to match. Begin with one spline directly at 12 o'clock. Take the crank and align it pointing down at 6 o'clock. Now thread on the crank bolt, feeling that it goes on smoothly and nice. Full engagement. This crank bolt can now be tightened fully to manufacturer's specification. With one crank fully installed, we now install the opposite arm 180 degrees, the opposite direction. Engage on the spindle and thread in the crank bolt and secure to manufacture.